So let's work on chapter 3. So what did we talk about last week? Anybody know? We talked about matter.
Compounds
And we separated matter into different classifications, right?
homogeneous and heterogeneous.
Well, wait a minute, let's get there. With pure substances, and pure substances are made out of what? Elements or compounds. Compounds are combinations of elements, right? And where do you find the elements?
Periodic table.
Periodic table. It's called a periodic table. And then you could have mixtures. Mixtures are combinations of compounds, right?
Yes.
And they can be homogeneous and heterogeneous. Homogeneous means
It becomes
The same thing.
homogeneous is the same throughout. Heterogeneous means not the same throughout. Okay? So, we're going to start talking about the transitions or changes in states. Okay? So, first we're going to talk about states. These different things can exist in different states of matter. We're talking about states of matter. You want to name the 3 states of matter?
solid, liquid, gas.
Solid, liquid, gas. Who else does number 3 like this? Most people do number 3 like that. I do 3 like that. It's a baseball thing. Baseball thing. It's very clear that that's 3. That's 2 and that's 3. It's very clear that that's 3, right? So 3 states of matter, normal states of matter, solid, liquid, and gas. We're going to define each one of them, and then we're going to talk about how you change from one to another. Okay, here they have a certain state of matter. They have liquid, a homogeneous mixture. We talked about salt ponds last week. They evaporate the liquid, and they collect the salt. Okay, so first state, solids. Solids are boring. They don't do a whole lot. Right? This table right here is not going to do a chemical reaction unless I force it to. Okay? In a solid, they have a definite shape. The shape does not change for a solid. It's fixed in shape and it has a fixed volume. We'll talk about volume and how much space it takes up, right? If I come in next week, this table isn't suddenly going to be twice as big, right? It's there. It's done. And it's still going to be the same shape. Right? It's not just going to change shape spontaneously. The reason it's like that is because the particles are very closely packed together. How do I know the particles in this table are very close together? I can't get anything between the particles, can I?
No.
I can't put my fist through this table. What? It'll break my hand, right? It'll hurt. Okay? The particles are very close together, and the particles are not free to move around.
I forget, I don't.
That's why I don't mind sitting here. Although I did watch one of the videos the other day, and I could see the back of my head in the video. So, the particles are not free to move, which means that if I come in today and I was able to label one of the molecules in this corner of the table here, when I come in next week, it will never be in that corner of the table over there. It's not going to move. It's going to stay right here, fixed in space and close together. That's what makes it a solid. Okay? Now, liquids are different. Okay? They take on the shape of whatever container you put them in. So she takes the water in that bottle. So Megan takes her water. It's in a bottle. See, I'm learning names. Megan takes the water, because Megan came to see me today and ask questions, and pours that water out on the floor. What shape does the water take on when she pours on the floor?
Shape of the floor.
Yeah, it takes on the shape of the floor. It would eventually fill up the room if she had enough water, right? If she pours it in a little tiny cup, what if she pours it in a long, tall cylinder? It takes on the shape of whatever you put it in, right? Does the volume change? No, the volume stays the same, right? Whatever it is fixed. Now, what about the particles in a liquid? They're different than a solid in that if I were to label a water molecule in her water bottle, if I came back a few minutes later, that molecule will have moved. It's free to move, okay? But the particles are still pretty close together. Has anybody ever moved through liquid before?
Yes.
Yes.
Yeah. Takes some effort though, doesn't it? If you go swimming, you get out of water, you're tired, right? Because it takes a lot of energy to move through the water. Because the particles are pretty close together. Okay? Unless all you do is sit there on your float, and that's not swimming, right? Okay. So the particles are close together, but they're free to move. Takes on the shape of the container and has a fixed volume. That defines this being a liquid. Now gases are special in that they take on whatever shape you put them in. So they have a picture of some balloons there. Anybody ever got any balloons that were not round like that?
Yes.
Go to Disney World, get yourself a Mickey Mouse head balloon, right? Kids loved them when they were little. Why was it that shape? Was it the gas that did that? No, it was the shape of the balloon. The gas I put in the balloon took on the shape of that balloon, right? Okay, so gases do not have a fixed volume and they do not have a fixed shape. They take on whatever shape and volume you put them in. And now for solids and liquids, the particles are pretty close together. For gases, they're very far apart. How do you know that? Anybody have any evidence that the particles in a gas are far apart?
The air is, you see smoke? Yeah.
I didn't know how to describe
Put your
it.
hand through it.
Look,
What air?
is there any resistance right there?
No.
Am I moving my hand through gas?
Yeah.
This room's full of gas, isn't it?
Yes.
Full of nitrogen and oxygen gas. Doesn't take a whole lot of energy to move through that. A lot different than trying to move through the table or even through water, right? The particles are far apart. Doesn't take any energy to move through. Where did I put that table? It's too small. Okay, so look at each one of these, and then we're going to vote. Remember our voting system, 1, 2, or 3 to answer? Okay, so let's vote. 1 is a solid, 2 is a liquid, 3 is a gas. Which one has definite volume but takes on the shape of the container? Solid, liquid, gas. 2, right? Liquids take on whatever shape of container you put them in, right? But the volume doesn't change. You can pour them into 100 different ones. Every time you pour it, you still have the same volume, but it takes on the shape. Particles are moving rapidly. 3, right? It's a gas. They're moving really fast. They're far apart. Okay? Particles fill the entire volume of the container. Pick 2, 3, 2, 3. It fills the entire volume. Okay. Look at her water bottle. Look at Megan holding up the water bottle. Is that liquid filling up the entire bottle? Not liquids, is it?
No.
So what do we think?
3.
Okay. The air in this room fills up the whole room. It doesn't all sit in one corner, does it? We'd all be over there trying to suck some oxygen out of the corner, right? All right. The air gases take on the size and shape of the container. Particles have a fixed arrangement. They're not free to move. Uno. Particles are close together but moving rapidly. Who do we say that is? All right, think about it. They're close together. It can't be a gas because in a gas they're far apart, right? So I can move through them. Can't be a solid because why?
They move very slowly.
Solids, they don't move at all, do they? Really? All they do is vibrate. It's got to be a liquid, okay? So they're free to move.
It didn't say move fast, though. I wrote move slowly on this.
Well, fast, slow doesn't really matter. In a solid, they can't really move at all. They can vibrate. That's all they can do. All right, physical properties versus chemical properties. Physical properties are characteristics that you can observe without changing the identity of a substance. So like, I keep picking on Megan's water bottle because it's a great example. Can you observe anything about her water today? What color is that water? It's clear. Could you figure out what temperature it freezes at? Yeah, put it in the freezer, put a thermometer in it, watch it, right? Could you figure out what temperature it boils at?
Sure.
Would you change the fact that it's water when you froze it or boiled it?
No.
It would still be H2O, wouldn't it?
Yeah.
Okay. What about the density? Can you measure the density? We did that in lab. Yeah, get mass, figure out volume, and density. Okay. So all those things that you can measure without changing the identity of it. Okay. So and here's their example of some copper. Okay. Anybody ever seen copper before?
Yes.
It's red, kind of reddish, shiny. It's copper color, right? Very distinct color. It's shiny in general. It's a good conductor of heat and electricity. How do we know that? We use it in our copper wiring in the house. Doesn't change the fact that it's copper wire when electricity flows through it, does it?
No,
No.
it's just conducting.
Yep. The solid at room temperature, as opposed to that water, which is a liquid, and it has extremely high melting and boiling points, right? It melts at 1,083 Celsius and boils at 2567. Yeah, that's very high. Okay, so identify the states of matter for the following. This is blurred amount. Vitamin tablet. It is a vitamin tablet. The one I take every morning is a solid. I guess you can get vitamins in liquids, huh?
Not a tablet.
Not if it says it's a tablet. That's not a liquid, is it? Eye drops. Drops imply liquids, don't they? Vegetable oil.
Liquid.
It's a liquid, normally, right? What about Crisco? Solid. Vegetable oil, isn't it?
Oil.
It's vegetable oil. It's been changed. It's been hydrogenated. But for the sake of this, we're talking about liquid, right? You go to the store, ask them for vegetable oil, you get a liquid, right? Candles.
Yeah.
Oil.
When I buy my candles, they're solid, right? When I light them, it changes them, melts them, right? I can melt it, but at room temperature, candles are normally a solid. What about the air in your tire in your car?
Yes.
Gas, right? A physical change occurs when something changes state. So you can change state from solid, liquid, gas. How do you change state from solid, liquid, gas?
Boiling
Heat.
freeze, stop freezing.
And what is heat? What's heat? It is energy. We can change the amount of energy something has, and we can change the state that it exists as. Solid, liquid, gas. Generally, solids have low energy. How do we know that? Because they're not moving, are they? Liquids have higher energy because the particles are free to move, and gases have very high energy. Okay? We talk about these transitions from one state to another. We'll talk more about it. So, examples of physical changes. Water boiling to form water vapor. Steam. Didn't change the fact that it's water, it just changed state from liquid to gas. Paper cut into tiny pieces in confetti. Didn't change the fact that it's paper, that's purely a physical change. When I take, we were on a food roll in the last class, when I take a chocolate cake and cut it into little pieces, or big pieces, it's your birthday, you get a big piece, right? Chocolate cake, I get a bigger piece. When I cut that cake up, what did I do to it? Just made a physical change. I didn't change the fact it was chocolate cake, did I? With sprinkles. And my chili from lunch is back gone.